Welcome back to Java Internals Crashcasts. I'm your host, Sheila, and today we're diving into the Flow API, introduced in Java 9. We're currently in our advanced topic season, exploring reactive programming. Victor, are you ready to help our listeners understand this exciting addition to Java?
Absolutely, Sheila. I'm thrilled to discuss the Flow API and its impact on reactive programming in Java.
Great. Before we begin, listeners, make sure you're familiar with the basics of reactive streams that we covered in our previous episode. Now, let's kick things off with a quiz question. What is the primary purpose of backpressure in reactive streams?
Ooh, that's an excellent question, Sheila. It really gets to the heart of one of the key challenges in reactive programming. I'm curious to see how our listeners will approach this. It's not just about data flow, but about managing that flow efficiently.
Indeed, Victor. While our listeners ponder that question, let's start with the basics. Can you give us an overview of what the Flow API is and why it was introduced in Java 9?
Certainly. The Flow API, introduced in Java 9, is Java's standard implementation of the reactive stream specification. It provides a set of interfaces that enable asynchronous stream processing with non-blocking backpressure. The main goal was to standardize reactive programming concepts within the Java ecosystem.
That's interesting. So it's like Java's official stamp on reactive programming. Could you break down the main components of the Flow API for us?
Of course, the Flow API consists of four main interfaces. 1. Publisher, which is the source of data items. 2. Subscriber, which is the consumer of those items. 3. Subscription, which represents the link between a publisher and a subscriber. And 4. Processor, which is a combination of both publisher and subscriber. These interfaces work together to create a reactive stream of data.
I see. So if I understand correctly, it's like a conveyor belt system in a factory. The publisher is like the machine producing items. The subscriber is the worker picking up items, and the subscription is the conveyor belt itself. Is that a fair analogy?
That's an excellent analogy, Sheila. And to extend it further, the processor would be like a station on the conveyor belt that modifies or filters items before passing them along. Your analogy also helps illustrate the concept of backpressure. Imagine if the items were coming down the conveyor belt faster than the worker could handle them.
Ah, that makes sense. Speaking of backpressure, how does the Flow API handle this crucial aspect of reactive streams?
Great question. Backpressure is managed through the subscription interface. The subscriber can request a certain number of items using the subscription.request method. This allows the subscriber to control the flow of data, preventing overwhelming situations.
That's fascinating. It seems like a really powerful feature. Can you give us a real-world example of where the Flow API might be used?
Certainly. One common use case is in data streaming applications. Imagine a system processing real-time stock market data. The stock exchange could be the publisher, sending out constant updates. Various applications analyzing this data would be subscribers. The Flow API allows these applications to process data at their own pace, requesting more data only when they're ready to handle it.
That's a great example, Victor. Now, I'm curious about how the Flow API compares to other reactive libraries like RxJava or Project Reactor. Are there any significant differences?
Good question, Sheila. While the Flow API provides the basic building blocks for reactive programming, libraries like RxJava and Project Reactor offer more extensive features and operators. These libraries actually implement the Flow API interfaces, providing additional functionality on top of them. So you can think of the Flow API as the foundation and these libraries as more feature-rich implementations.
I see. So developers might use the Flow API directly for simpler use cases, but turn to these other libraries for more complex scenarios.
Exactly. The Flow API gives you the basics, while these libraries provide a wider range of tools for complex reactive programming tasks.
That makes sense. Now, are there any common pitfalls or misunderstandings that developers should be aware of when working with the Flow API?
Absolutely. One common mistake is not properly handling backpressure, which can lead to memory issues if a slow subscriber is overwhelmed with data. Another pitfall is forgetting to call the subscription.request method, which can result in no data being processed. It's also important to remember that the Flow API is designed for asynchronous processing, meaning operations can happen independently and out of order. So developers need to be mindful of thread safety issues.
Those are great points, Victor. It sounds like proper backpressure management is crucial. Speaking of which, I think it's time to reveal the answer to our quiz question. The primary purpose of backpressure in reactive streams is to prevent overwhelming the consumer with more data than it can handle, allowing for efficient data processing and resource management. Victor, any final thoughts on this?
That's spot on, Sheila. Backpressure is indeed a critical concept in reactive programming. It ensures that fast producers don't overwhelm slow consumers, leading to a more resilient and efficient system. It's like having a smart conveyor belt that adjusts its speed based on how quickly the workers can process items.
Thank you, Victor. That wraps up our discussion on the Flow API in Java 9 and beyond. To summarize the main points. 1. The Flow API is Java's standard implementation of reactive streams. 2. It consists of 4 main interfaces: publisher, subscriber, subscription, and processor. 3. Backpressure is managed through the subscription interface, allowing subscribers to control data flow. 4. While the Flow API provides the basics, libraries like RxJava and Project Reactor offer more extensive features. 5. Proper backpressure management and understanding the asynchronous nature of the API are crucial for effective use. In our next episode, we'll be looking at reactive libraries like RxJava and Project Reactor in more detail. Don't forget to subscribe to Java Internals Crashcasts and leave us a rating if you enjoyed this episode. Until next time, keep coding and stay reactive.